last video I have already given the overview of the project. So in this video we'll start the implementation of the project. So this is a folder. Inside this we have all the files. So I will share these things in my GitHub repository. Okay, so for now I've already created the copy of this here. This is a plant disease detection copy folder. So inside this I will work. So make sure that you have this dataset downloaded and these three folder you have in your directory. So I will start my implementation from here. Okay, so this is a validation folder, this is train folder, and this is test folder. So this test folder contain the images on which we test our model, and this train folder contain the classes of all the images on which we have to train our model. Okay, so if you see here, apple scab, this is a type of disease in the plant. So if I go inside this, then if you will see that this is a disease in this plant. Okay, so this is a apple scab image, and this apple black rot, this is some other kind of disease. So this is the image of that. If you see this brown part, so this is a different type of disease in apple plant, and these are some healthy images of apple also. So we have to train our model in such a way that model can identify that this is some healthy image of apple, or is it some disease in apple, or what is that. And we don't have only apple, we also have other plants like cherry. So these are some healthy images of cherry. Similarly, we have list of all other plants, and this is a validation folder here. So we will do our training by using this entire list of images, and for testing purpose we will use this validation folder to track the history and to track the accuracy of our model, and for final testing we will use this test directory. Okay, so this is the significance of these three folder. Now I hope that you guys have familiarity with the data set, what is the structure of the data set. Now we'll start our implementation. Okay, so just open terminal or command prompt what you have. So if you are Mac user, then open your terminal, or if you are Windows user, then open your command prompt. And here I am using Anaconda, so I am activating my TensorFlow environment. Okay, so my environment is activated. So I have opened my Jupyter notebook here. And one more thing, if you don't have Jupyter notebook, then just go on command prompt, install Jupyter notebook by using pip install Jupyter notebook. Okay, so this is my Jupyter notebook. I hope everyone have Jupyter notebook. My directory is inside desktop, so go inside desktop, and if you go here, then you will get this plant disease detection copy folder. So this is my entire working directory. Inside this I will do all the things. So just go here and just click on notebook, then we will open our notebook. So from here just select your kernel. So I'm using this Python 3.10 TensorFlow environment. So just select your kernel, and we are now ready to start our project. Just write it as a train plant disease. So this is my IPONB file which is here, which is created. So if I refresh it, then you will see here. Let me give some markdown. So I am giving markdown as importing libraries. What libraries I need here? So first of all I need TensorFlow STF, and second library I need for visualization is import matplotlib matplotlib.pyplot as plt. Okay, and I also need pandas. These are some basic libraries which are needed, and for data visualization purpose maybe I will use in between somewhere cborn. So use import cborn as SNS. Okay, so for now I need this much of library, and if somewhere in between I need something else, then I will import that one also. Okay, for building our neural network and feeding our data to the neural network, we have to do some pre-processing first, then we are going to feed those images to our neural network. Okay, so to perform pre-processing, let me show you how we can do pre-processing. So first give a markdown data pre-processing, and first we are going to perform a training image pre-processing. So just give here markdown of training image pre-processing. Okay, and to perform your training image pre-processing, what you have to do to build any machine learning project, you can't remember each and every line of code every time, because suppose today you are writing something and after some time new version of TensorFlow or Keras came and that thing is replaced by something else. Okay, so you have to be updated with your code. Okay, so to perform training image pre-processing, we are going to use Keras library. So let me show you the documentation of Keras, so from there you will understand better. Okay, so just type here Keras image data loading, this thing. Okay, so here I will give the link of this also in description. Just open this keras.io/api/data_loading. This is a image data loading, so this thing I am going to use from here. Okay, so just copy this entire piece of code and go here and just write here training set, just paste it here. Okay, so this library I am going to use, but this is a Keras, but I am using TensorFlow higher version, so just use here tf dot, because TensorFlow Keras is a part of TensorFlow. Just use here tf.keras.utils.image dataset from directory, this class I am using, and this class will take first input as your directory. What is your directory name? So here our directory name is this one, train. So this thing you have to give here, so just write here train, and labels is equal to inferred, and level mode is equal to this thing. I will explain you how we are doing this and what is the meaning of these things. So just go here. So this is the image data set from directory class. So if you see the arguments, what is the meaning of these things? So then directory represent that directory where the data is located. So that is exactly the location of our data set, this train folder. Okay, what is the location? And labels, either inferred, labels are generated from directory structure. None means no label, or list of tuples you have to pass here. And label inferred means that labels are generalized from directory structure. That's what the meaning of inferred means. What means that if I go inside this training folder, then you will see the directory name. So if I set there here label is equal to inferred, means that I am saying to TensorFlow that go inside this folder, go inside my train folder, and whatever is the name of the directory, select it as my label. Okay, that's the meaning of this label is equal to inferred. And label is equal to int means that if you go here, label mode is equal to int means that labels are encoded as integer, example for sparse categorical cross function. So for here I will not use int because my label is in text form. Okay, so I will use label mode as categorical, means that label are encoded as categorical vector. I want my label as a categorical vector because I am not solving here two class problem, it's a multi-class problem, more than two class. So that's why I will use here label as categorical. So just replace this thing as categorical. And if you want to learn more about this thing, then please visit this source. If you go inside this source, then you will learn a lot of more things. If you go here, then you in comment you will see all the things that categorical means that labels are encoded as categorical vector. Binary means that labels are encoded as float 32 scalar with value 0 or 1. If I am solving two class problem like cat or dog problem, at the end of the training I want my model to predict between two things, then I will use label mode as binary. But here I am solving 38 class problem. Here I have 38 type of classes. I want to make my model in such a way that suppose if I am passing some image, then my model is able to say that out of this 38 classes, the probability of that this image belongs to this class is much higher. So that's why this type of things I want to use. So here that's why I have uses this categorical. And class name I don't want to give here, because if you see here only valid if label is inferred. Okay, this is explicit list of class name. So here I have already given my labels as inferred, so I am saying that go and take the label name same as whatever the name of the directory, okay, whatever the name of the classes of each directories, okay, this directory name take as label name. So here I don't want to give a class name, so I will put it as none, okay. And color mode I am going to choose as RGB, and for now the default batch size I will choose as 32. If I want to speed up my training process, then I will change this batch size to 64 or 128, but for now I am putting it as 32, okay. And image size I am going to put right now as 128, okay. And shuffle I am going to shuffle it, so I am going to put it as true. Shuffle means that at the time of feeding to my model for the training, shuffle the entire thing and pass it, because it will reduce the biasness of the model, okay. If I shuffle it, then my model will learn from all end, okay. Suppose if I don't shuffle it, then first this directory images will be passed, then this will be passed, then this will be passed. This is not a good thing. So shuffling means that randomly it will take this training example, then this training example, then other training example, so it will learn better, okay. That's why I am putting here shuffle as true. And seed value and validation split, this thing I am not selecting here. This thing I am using whatever it is, okay, default value I am choosing. If you want to learn about all this argument, then please visit this documentation of Keras, and if you go here, then you will see all the things like whatever I have explained about shuffle, whether to shuffle the data, default to true, if set to false, sort the data in alphanumeric order, okay, and according to that it will feed to the neural network, okay. So shuffle has very important role. Later we will use this thing when we are going to test our model, so then you will see the difference of shuffle is equal to true and shuffle is equal to false, okay. So this is all about this documentation, so please visit this documentation to learn about how you can load image for your neural network, okay. So this thing we have done. And now for validation, because we are also going to track the accuracy and performance of our model while training, so we need our validation set also, okay. So here what I will do, here I will write validation image pre-processing, okay. And what I will do, I will copy this entire thing here also, and I will change it at valid, because if you go here, then my directory, this validation directory name is valid, because we are on the same hierarchy. So I will just pass this train and valid name, it will capture my directory location, okay. So the same thing I will use whatever I've used for training set, and I will use here validation set. So this is my validation set. So if I go here and run this piece of code, it's saying that unknown argument data format is passed, okay. So data format we have passed here data for, okay. So we don't need to pass this thing here, okay. So just remove this thing from here. If you go here, then you will see that what is the meaning of data format. If none, use keras.config.image data format, otherwise either channel last or channel first, okay. So if I'm using as data format as none, then we have to use some other things like this keras.config.format. So we don't want to use these things, so just remove that part from here and run this. If you run this thing, then you will see here found 70,295 files belonging to 38 classes. So Keras is able to detect the 38 class, and the total files inside this 38 class is the total file inside this training set is 70,295, okay. So similarly run this also. So here Keras is Keras identified that found 17,1572 files belonging to 38 class. So we have successfully completed our data pre-processing. If you go and see the variable, then you will see here this is a type of prefetched data set, and tensor space is 128 cross 128.3. 3 represent the RGB image, and this is the size of the image 128 cross 128 we are using here. And tensor space, this one is y is this 38. Okay, so this is my x variable and this is my y variable. So if you see here, this is 38 class. So the data set is in such a way that if I go here and show you for x comma y in training set, print x, and I just want to print first element of this both, and then break the loop. So this is a data set. Print x comma x dot shape and y comma y dot shape. From here you will see more clearly. So this is a shape of if you see here, this is my x, this entire thing is x, and this thing, and this is y. Okay, so y contain 32 cross 38 means that these are the levels. Okay, and 32 means that we are passing it in 32 batch, because here we have set the batch size as 32, so it's going in 32 training example first. So at each time when we are iterating over training set, then it's going 32 images of 128 cross 128. Here 32 levels are going, so it's showing the label and it's showing the value of the image. Okay, so at a time we are feeding 32 images. Okay, if you see here, so once we are going to train this entire thing to our neural network, then at a time 32 images will be fed to the neural network, and it will be shuffled, and also its label also will be passed. All 32 images and all 32 labels will be passed to our neural network, and neural network will learn to fit those images with respect to the labels. Okay, so that's what we are going to perform next. Okay, so we have successfully created our training set and test set, if you see here. Okay, so let me summarize what we have done so far. So first of all, we have imported all the libraries, and then we have done this training image pre-processing, in which we have selected the batch size as 32 and label is equal to inferred, which means that I am saying that take all the label as the directory name of my class, and label mode I am selecting as categorical, because here we are dealing with more than 2 class problem. If there is 2 class, then we will put the label mode as binary, but here there is more than 2 class, so I will put the label mode as categorical. And this color mode I am choosing as RGB, and image size I am choosing as 128 cross 128. Shuffle I am going to put as true, and rest of the things I am putting as usual. The same thing I have done for validation image pre-processing. And then in this part we have seen the structure of our training set. So to see the structure of my training set, I am iterating over x and y in training set. This x is my training example and this y is my label. Okay, and I am printing my first x and first y here, and then I am breaking the loop. So if you see here, this entire thing is printed, and it's saying that this is a shape of x, and this is a shape of, if you see here, I have already done here x dot shape. So this is a shape of x and this is a shape of y. So what is the meaning of this? The meaning is that at a time it's feeding 32 images of the training set and 32 labels of the training set. If you see here, 128 cross 128 and this 3, this represent the size of the image. This 128 cross 128 is the width and height of the image, and this 3 represent the color of the image, that is RGB, because we have selected here color mode as RGB. and this 32 represent that at a time we are feeding 32 training example. So that's why when we are iterating over x and y in training set, then at first attempt we are getting 32 training example, 32 images, okay, and corresponding 32 levels we are getting. So in future when we are going to feed this entire thing to our neural network, at a time it will pass 32 training example. That's the meaning of the batch size. Here we have selected batch size as 32, means that when we are going to feed this entire data set, this entire data to our model, then at a time it will pass 32 training example. Okay, so that's how you can inspect your training set. So that's all for this video. In the next video we are going to build the architecture of our neural network. So thank you guys, thanks a lot for watching this video. We will meet in next video.